our next thing for right triangles is going to be using a geometric mean to solve embedded right triangles. So a few vocabulary things to cover here. First off, what is a geometric mean? Well, without getting into too much detail, geometric mean is an average of two values using multiplication and square roots. That sounds really complicated, but what we want to be able to do is we want to be able to identify a geometric mean. So an example of a geometric mean is something like x over 2 is equal to 8 over x. So what makes this a geometric mean is if you notice your x and your x, one is a numerator and one is a denominator. So when you have the same value as a numerator and a denominator, then we are setting up a geometric mean. Now the way we would solve this is we would go through our cross multiply, which in middle school you would have called it butterfly method. You would say x times x. Well, x times x is x squared. And then you would say 2 times 8 is 16. And now we get x squared is equal to 16. And as we did with Pythagorean theorem, once you have squared, we need to take a square root. So the square root of x squared is x, and the square root of 16 is 4. So that would be the geometric mean of 2 and 8. So cross multiply, square root, that's how you do geometric mean. All right, next thing here was embedded right triangles. Now when you think embedded, you need to think inside. So the easy thing to do would be to look at these two problems here. We have a big right triangle. So there's our big right triangle. And then inside of that triangle, we have a triangle over here on the right. I'm not tracing the best. I'm just making sure we can see it. And then we have a triangle over here on the left. So my blue and kind of purple color here, they are inside the green triangle. So we say that they are embedded in the green triangle. So embedded, think inside. All right, so here we go. Now there are long ways to do these problems and then there are short ways. And we're here today to do the short ways to do these problems. So what we need to do is we need to think about, we have these right triangles. And I'm going to come over here and just sketch one real quick. So we have these right triangles. There's my right angle. And then we have this line that comes down from the top. And that also creates a right angle down here. Now this line here is what we call an altitude. Now when you see the word altitude or hear the word altitude, you should think the height. So how tall is that triangle? Okay, so the height of that triangle. So that's an altitude. Now, if we think back to the big triangle, so thinking about the green triangle over here, the big triangle, then this would mean that this is our hypotenuse. So think back to your Pythagorean theorem. There's your hypotenuse based off this right angle. And then this would be a leg. And then this would be a leg. So when you think back to your a squared plus b squared equals c squared, there's your a and your b and then your c. But now that we've put this altitude in, we also have other triangles. So they also have their own legs and hypotenuse, and it gets really, really complicated. Because now you're like, oh, well, if this is a right angle, then this leg is really a hypotenuse for this small triangle here. It gets really complicated. But what we have is one big triangle that has now been split into 3 triangles. The big one, the left one, and the right one. And we're going to find the shortcuts on how to find this missing sides. Okay, so here we go. First one is called the altitude theorem. So the altitude theorem, you're going to need the altitude or be trying to find it. So either we need to know the altitude or we need to try to find it. So real quick, let's look at these two examples. So there's X here. So this is my altitude. But when I come over to this one, there's nothing on the altitude. That's my altitude line there. There's nothing there. There's no variable. There's no number. There's nothing. So over here, I can use the altitude theorem, but as you can see, this is not altitude theorem. We'll talk more about this one in a second. Okay, so let's come back over here. So the altitude theorem. So when we have the altitude, notice that once you create this altitude, we now have these two parts down here. We have a 6 over here, and we have a 3, and then we have the X. And that 6 and the 3, think about it up here. Like this is your 6, and this is your 3. So together, they make up your hypotenuse. But what they've really done is they've created two parts. And what we like to say is we like to say that this is part 1, and this is part 2. Now I could easily make that part 2 and part 1. Either way, the two parts make up the hypotenuse. Okay? All right, so now here is the shortcut. So we're going to set up our geometric mean. To solve for the altitude. All right, so for the geometric mean, X is your altitude. So the geometric mean for the altitude theorem is altitude, altitude. Now, the altitude is the numerator and the denominator. Now notice that's just like our geometric mean. X was the numerator and denominator. So they repeat. So that means geometric mean. They repeat, so geometric mean. And this is going to be part 1, and this is going to be part 2. Okay, so now let's come down and let's plug in what we have. So the altitude, I go back to my diagram, and I say, oh, altitude is X. So X and X. Part 1, well, I'm going to let this be part 1, and I'm going to let this be part 2. So 6 and 3. 6 and 3. Okay, so now I am set up. I know I'm set up correctly because I have a geometric mean. Again, the x's are repeated. X's are repeated. So I cross multiply. X times x gives me x squared. 6 times 3 gives me 18. Now when you get to this, you notice you have x squared. So what we need to do is we need to take a square root. Boom, boom. All right, so now time to get the phone back out. Calculator for you, hopefully. And what we need to do is we need to take the square root of 18. All right, so I type in 18, and I'll do the square root, and I get 4.24. That 4 is not bigger than 5, so just 4.2. So x is about 4.2. Okay, so that's using the altitude theorem. Again, we're finding the altitude, the height. All right, so now we come over to this one. And we just learned the altitude theorem, but then we look at this one and we're like, oh, there's no altitude there. No altitude. Here's my right angle. So this right here is my hypotenuse. And now if those are my hypotenuse there. There's my altitude. And then these are my legs. So this is a leg and this is a leg. But notice that there's nothing there. So I don't even care about that leg. All right. But since we have two legs, we're going to call this leg 1. And now we still have our two parts. Since this is leg 1, we're going to let this be part 1. And we'll let this be part 2. Okay, so here is the leg theorem. So the leg theorem we're going to use when we do not need the altitude. So we're not looking for the altitude. We don't know it. We don't need anything with the altitude. So there's no altitude there. Over here we had x. Here we have nothing. Okay, so here we go. So what does the leg theorem look like? So we're looking for leg 1. So leg 1. And now the other two pieces of information are going to be part 1 and the whole hypotenuse. Okay, so let's see what we have so far. So leg 1 is y. So we have y and y. And then part 1 is 2. But now what is the whole hypotenuse? Well, remember the hypotenuse is cut into 2 parts. Part 1, part 2. So 2 plus 5 gives me 7. So if we're going to use the leg, I would use y, 2, and 7. Now if I was looking for this leg, I would use this leg, 5, and 7. But since we want leg 1, part 1, whole hypotenuse. Okay, so there we go. We're set up. There's our geometric mean, y and y, cross multiply. Y squared is equal to 2 times 7 is 14. We know we have to do the square root, so y is about I'll type in 14, square root of that, 3.7. Okay. All right, so there's your two theorems. Altitude theorem, leg theorem. And the two things we really need to know is this and this. And that's going to help us with this. Okay, so we're going to do one more together, and then you'll have 2 practice at the bottom. First things first, label everything that we know. All right, check for the altitude. So x right there, there's my altitude. So if I have an altitude, that means I can use my altitude theorem. So we'll get back to that in a second. All right, so now I'm thinking, all right, oh, this is a leg, and this is also a leg. This z is a leg. Well, I'm just going to let this be leg 1, and we'll let this be leg 2. So that means that 5 is part 1, and then 15 is part 2. But then I also know I need the whole hypotenuse. And that's 5 plus 15 for a total of 20. Okay, now we can kind of start where we want. Most students choose to do altitude first. So my altitude is x. And I'll look back, I just learned this. So altitude, part 1, part 2. So that means I need x, 5, and 15. So I'm going to say I'm solving for the altitude. So set up my fractions, altitude, x, part 1 is 5, part 2 is 15. Cross multiply, x times x squared, 5 times 15, 5 times 15, 5 times 15 gives me 75. But now remember that this is x squared, so I need to take the square root. So x is going to be approximately, I need to take the square root of 75, square root, 8.66. After that 6 is a 6, so it's going to round up to 8.7. 8.7. All right, so the altitude is done. So now I got to do the legs. Now it doesn't really matter which leg we do first. We can do leg 1 or leg 2. I'm just going to go leg 1. So I'll bring that over here. So leg 1. So I set up my fraction. So maybe I forget and I come back and I say, oh, well, leg 1, part 1, whole hypotenuse. So I like to circle what I'm going to use. All right, so leg 1 is z, part 1 is 5, whole hypotenuse is 20. So z, 5, 20. Cross multiply, z times z is z squared, 5 times 20 is 100. And then we take the square root. So the square root of 100 is 10. All right, and now we just have to do leg 2. So the last thing we need to do, we'll come over here and do this one. So leg 2, that is going to be y. If leg 1 uses part 1, then leg 2 uses part 2, and then the whole. So y and y, 15 and 20. Cross multiply, y squared, 20 times 15 is 300. And the square root, so y is going to be about, need a little help with this one. So 300, square root of 300 is 17.3. And there you have it. So a lot going on. So we have an altitude theorem, legs, all three answers, 8.7, 10, 17.3. Okay, you have 2 questions down here at the bottom. Follow this example here to do those.